Right now, at this very moment, our entire galaxy, the Sun, the Earth, every star we've ever known, is being dragged across the universe at over 2 million kilometers per hour. Dragged by what? A supermassive object? A hidden cosmic structure? Something we don't have a name for yet. Astronomers call it the Great Attractor, and despite decades of study, we still have no idea what it actually is. Today, we're going into the heart of one of the most disturbing mysteries of modern cosmology, a force so massive it's warping the motion of galaxies across hundreds of millions of light years. The cosmic current we can't escape. When astronomers measure the motion of galaxies, they expect the universe to expand uniformly, everything moving away from everything else. But that's not what we see. The Milky Way isn't drifting randomly. It's moving in a very specific direction, toward the constellation Centaurus, at a speed that cannot be explained by cosmic expansion alone. Even stranger. Every galaxy in our local region, Andromeda, Triangulum, the entire local group, is headed the same way. It's as if we're all caught in a slow-motion cosmic river. We call this mysterious gravitational flow the Great Attractor. Hidden behind the Zone of Avoidance, you think we could simply point a telescope toward the source and find the answer. But there's a problem. The Great Attractor sits behind the Zone of Avoidance, the brightest and most crowded region of the Milky Way sky. Billions of stars. Dense molecular clouds. Torrents of dust and gas. For decades, this region was completely impenetrable. It was the blind spot of astronomy, a literal hole in our map of the universe. The perfect place for something enormous to hide. What we can see, so what do we actually know? Not much, but enough to be terrified and fascinated. Infrared surveys began to reveal a massive concentration of galaxy clusters about 200 million light-years away. The center of this region is the Norma Cluster, containing thousands of galaxies. This alone could explain part of the gravitational pull, but not all of it. Not even close. The mass we can see accounts for maybe 10 to 20% of the force that's dragging our galaxy. Something else is out there. Something far more massive, and much harder to detect. The Shapley Supercluster, a bigger monster. 7:30 to 10 o'clock, narrator. In 2005, a shocking discovery rewrote the theory. Deep beyond the Great Attractor lies an even larger structure, the Shapley Supercluster, one of the biggest concentrations of galaxies in the known universe. Its mass is incomprehensible, over 8,000 galaxy clusters, hundreds of thousands of total galaxies, trillions of stars. Some astronomers believe this is the real culprit, the structure truly pulling us in. But the mystery gets deeper. Because even the Shapley Supercluster is not quite enough. The dark flow problem. A few years ago, NASA's WMAP and Planck satellites found something impossible. Galaxy clusters across an enormous region of space are all moving in the same direction, toward a point beyond the observable universe. This is known as the dark flow. Some scientists now think the Great Attractor may be the tip of a larger gravitational structure, crossing the boundary of our observable universe, a hint of mass existing outside our cosmic horizon. In other words, the Great Attractor may be only the local part of something unimaginably bigger. Is it dark matter? One hypothesis says that dark matter, invisible, undetectable, yet making up 85% of all matter, is concentrated in massive filaments behind the Zone of Avoidance. If true, the Great Attractor could be a dark matter superfilament, stretching hundreds of millions of light-years, pulling galaxies like beads on a string. But there's a catch. We've never successfully mapped dark matter in this region. We don't even know how much of it is there. The real structure could be far stranger than we think. Should we be worried? People often ask, are we falling into something dangerous? Is the Great Attractor a cosmic black hole? Could it swallow the Milky Way? The answer is, no, not in any way that affects us. Galaxies fall toward each other due to gravity all the time. This is normal at the largest scales. We're not spiraling into a monster. We're drifting along with billions of other galaxies, slowly, over billions of years. The hidden architecture of the universe, the Great Attractor, is not a threat. It's a clue. A hint that the universe is structured in ways we don't yet understand. Our galaxy, our home, is part of a vast, interconnected cosmic web, pulled by forces so large, so distant, so ancient, that we are only beginning to detect them. And somewhere behind the zone of avoidance, behind the curtain of our own galaxy, the answer is waiting. A gravitational fingerprint from something unimaginably massive. Something shaping the motion of galaxies themselves.